Okay, welcome back. I really like the ads. It's like we have the Python TV or something like that. So I hope everyone is enjoying the conference. I'm here to introduce Gina or Gina, and she will teach me how to pronounce that. I think you were. I was trying to learn that in some rehearsal and I failed. So hello,
Yeah.
welcome,
It's welcome. Hi. Thank you. Thank you for having me. Yeah, it's Gina actually. It's an Italian
Gina.
name, even
Okay,
though I'm German. So,
okay.
um, yeah, parents from
Gina,
Italy and Italy.
I can do a bit better. Cool.
No problem. Yeah,
So, where are you streaming from? Germany?
Germany. Yeah. So I'm about,
Uh,
I don't know, maybe 10 minutes from Frankfurt am Main here. So quite central in Germany. And
Nice.
yeah, it's a hot day. It's a warm day. I went rock climbing this morning, so I'm perfect right now.
Right. That's super nice. I have a super important question for you. Is it space or tabs?
I do understand the ideas behind PEP 8, and so I have switched my code to spaces, but personally, I've always been a huge fan of tabs, and actually tabs for indentation and spaces for alignment. That has always been my mantra. But I am playing by PEP 8's rules now, so yeah.
Nice. I really like now a lot of people will complain to you in the chat. So sorry about that. Okay, so Gina is going to be talking about driving 3D printers with Python. And yeah, so she's a passionate cold monkey gamer, hobby biker, and creator of and maintainer of OctoPrint. And I think she's going to be talking about that. So I'm not going to steal more time for you. And thank you very much for being here in EuroPython presenting. And I hope we see each other next year in Dublin. So yeah, the stage is yours. Good luck.
Thank you. Okay, so yeah, as I was already introduced, my name is Gina Häußge, and I'm talking to you today about driving 3D printers with Python, and more specifically, the lessons that I learned from that. Some words about myself first. Gina Häußge. The last name is actually usually making more people pause than the first one. I'm a software engineer, I'm a maker, I'm a hobby baker, 100% nerd, and I'm also in the happy position to be a full-time crowd-funded open source software developer. And I'm the creator and maintainer of OctoPrint, which is also the project that I am working full-time on, fully crowdfunded. What is OctoPrint? Well, it's the snappy web interface for your 3D printer. It's open source, licensed under AGPL v3, has currently something about 100,000 confirmed users, unknown actual number because the tracking is opt-in and GDPR conform and all that, so I only have a rough estimate there. The backend of this application is completely written in Python. The front end is your usual mix of HTML, CSS, and JavaScript, and you can find all out about this project on octoprint.org. OctoPrint is, as I already said, an application, so something that users install themselves. And the target audience for OctoPrint are, pretty much owners of consumer 3D printers. So the things that you can buy in your hardware, in the hardware store these days, actually, usually people who are makers and tinkerers who maybe want to print stuff for their miniature war games or terrain pieces or something like that, or who are into model plane flying and want to print parts for that, or who are just into 3D printing as a hobby. There are also some businesses here and there. So we are talking about end users, more or less, with some small exceptions. And these end users are rarely developers themselves. So we usually look at people who just take on a new hobby in the shape of a 3D printer, or who acquire a 3D printer for their business and they now want to drive it somehow, want to monitor it somehow. And this is where OctoPrint comes in. Additionally, OctoPrint targets, as the platform that it runs on, primarily targets small single PCB Linux computers, like, for example, the Raspberry Pi that you might have heard about. So small, cheap, $35 to $50, and easily just installed next to the printer with OctoPrint on it, and then you are ready to go. Important is that while OctoPrint primarily targets this platform, it still is platform agnostic. So if you still have a laptop gathering dust, you can also, if you desperately want to, throw some Windows on there and run OctoPrint from that. Or if you have an old MacBook, that also works. And this specific kind of target audience and platform restrictions, and also the whole thing that OctoPrint is an application installed by end users and run by end users, and in a way then also maintained by end users, makes for some unique challenges, or at least I found them to be pretty unique. Because the literature is full about challenges for library development, but not so much about challenges for actual end-user-facing applications. And I want to introduce you to 3 of them that I encountered over the past almost 9 years now of doing this project. Challenge number 1 is initial installation and keeping things up to date. So I already said that OctoPrint is installed on-premise by end users. So they download something and then have to install it themselves. Usually when you have some Python application, then you will just tell people that they just need to run pip install OctoPrint, preferably also bootstrap a Python environment in the first place. And then they are good. But this doesn't work with the end user, with the audience that we're talking about here. What OctoPrint instead does is that there is a pre-configured Raspberry Pi image that contains OctoPrint, contains all the dependencies, contains the whole Python environment already set up with the virtual environment, with all dependencies installed, with a C compiler installed for compiling native extensions and all that. And users can just download that image, flash it to an SD card, and then boot it up, and OctoPrint will then take it from there through a wizard and help them get started. So that has worked out really nice. The question, of course, is what about if you want to install it on something that is not a Raspberry Pi? Well, as I said, this is not the primary platform, so there will be some dragons, but it is in principle supported. There is a huge variety of encountered environments out there. So I've had people who have installed OctoPrint on FreeBSD. I've had people install OctoPrint on some old open WRT router that they still had lying around. Things like this, so that it can be very diverse and can pose some unique challenges actually with regards to dependency hell and all that. And that means that the code in OctoPrint needs to anticipate some of these things. So for example, the IPv6 dual stack on Windows works entirely differently between compared to Linux from a Python point of view. And file locking works differently. For example, I cannot just, I do have to keep things in mind when I do something like log rollover or things like that in my client code, because things are just not working as easily under Windows because you cannot write a file that is currently in use. So these are things that you have to keep in mind there. And then you now have installed it. What do you do now? How do you keep things up to date? Again, the usual approach here is to tell people, well, just run pip install -u OctoPrint and that will take care of that. But again, this is not really going to work out with the target audience here, because they usually don't even want to touch the command line, let alone run any kind of commands in there. So how I solved this in OctoPrint is that OctoPrint, as well as any kind of plugins that are installed into OctoPrint, more on plugins a bit later, there is an update mechanism for those built into OctoPrint, which itself is a plugin, by the way. But that basically takes care of this pip install -u in the background, gives everything a nice little UI. People get update notifications when something new is out, and they just have to click a button and everything will be taken care of them, making updating a very easy and straightforward appearance. So that is OctoPrint. What about stuff like pip? You might have seen this message there when running pip install or pip update or whatnot. You are using pip version X, however, version Y is available. It turns out that this is a very scary message for end users, because they see a message that looks like something is wrong, something is broken, and it tells them something cryptic that they should be doing, and they don't really know how to do that. And that has caused a lot of support overhead. In the end, the solution to this was actually to hide the message in the update dialog and instead offer an option to update pip separately, but only for power users, so to speak. And the underlying operating system, OctoPrint does not take care of that. Some users do update it, some don't. And the result is that we sadly also, once again, have to face a somewhat mixed environment, sometimes broken environment. It's hard to test. There's some additional support overheads caused by this. A lot of people are still of the conviction that never touch a running system is the mantra to go with these days. And I obviously do not agree. The only way to get people to actually install updates forever, at least in my experience, seems to be to tell them, here's a new feature, here's a bug fix. So that seems to work with motivating people to touch a running system and actually install updates in a very timely manner after each release. So lessons learned here is really try to control the runtime environment, but stay flexible enough so that you don't pretty much put people into a prison that you created. Make updates very easy so that that people will actually apply them, and also use features as a motivator for touching a running system and for getting people to apply the easy to apply updates in the first place. In short, really just enable them to keep their systems updated. Challenge number 2, maintaining backwards compatibility for a whole ecosystem. So I already dropped the word plugin here, and OctoPrint has now sported a plugin system since 2015, since version 1.2.0. And we now are looking at over 300 plugins registered on the official plugin repository. Plugins do stuff like you get an email notification when your print is done, or fancy time lapses that make the print look like it is growing out of the print bed. Workarounds for weird firmwares from 3D printer, from cheap 3D printers, and stuff like that. So we have a really established plugin ecosystem here now. And that means that suddenly OctoPrint is not just a little application that I just write in my home office here, but it is pretty much become sort of a platform. And the platform requires stability. Why? Well, if I constantly change everything and throw APIs away and fire up new ones and make backwards incompatible changes all the time, I don't think that plugin authors would be as motivated to actually develop against this platform as they are now, which means I don't have an ecosystem anymore, which means the users that are drawn to the ecosystem, partially even more so than the convenience that OctoPrint alone offers them, these users are now somewhat unhappy and disgruntled. So what does this mean? I actually have to spend a significant amount of time in OctoPrint's update cycle on pretty much going through dependency updates that I do need to do and check them for breaking changes, because it actually turns out that a lot of third-party dependencies regularly will break your code, even with patch updates. And the reason here is that even if I adapt my code for dependency changes, for backwards incompatible changes on third-party dependencies, if any kind of plugin now also uses the same version and does not anticipate this change, then stuff might break unintentionally on side of the user. Again, disgruntled user, unhappy user. We don't want unhappy users. So what I usually do here is when some kind of backwards incompatible change in an updated dependency rushes in, I look if I can somehow wrap it so that it becomes transparent for everyone using this code. Of course, that means a lot of work. It means a lot of version pinning. It means a lot of reading through changelogs and sometimes even commit histories. But it means also that there is a lot of stability on the platform. Another example where additional work and overhead is needed is code refactoring. If I spot a typo in my API, I cannot just fix that because someone might already be using this API. I have to think long and hard about any kind of changes in calling parameters or in return values or even just in side effects of certain commands, and that adds up. So usually that also means wrappers internally that make sure that every changes are handled transparently for any kind of calling code. And finally, the biggest challenge actually over the past years has been the whole Python 2 versus Python 3 migration situation. So as we know, Python 2 has been end of life since January 1st, 2020, but OctoPrint for the longest time actually only supported Python 2, because I will admit that was a big mistake of mine when I created this back in late 2012. I simply did never anticipate it to become a thing. And then it became such a big thing that I never found the time to actually do the migration in a timely manner. So yeah, things took a long while, and now I also had to worry about the whole ecosystem. And this was pretty much my whole late 2019 and full on 2020 that I'm going to talk about now, which is migrating an ecosystem to Python 3. So how I tackled this with OctoPrint was, I mean, it was absolutely clear that I had to make the cut at some point to at least make OctoPrint compatible to Python 3. For now, it also still supports Python 2, but also try to push the whole community, the Python authors, the plugin authors, and the users themselves over to Python 3. And that needed a lot of preparation, apart from just rewriting parts of OctoPrint or migrating parts of OctoPrint. And the approach here was, first of all, a long preparation and briefing period. So while I was still working on the migration of OctoPrint itself, I also worked with the community so that we could create some kind of migration guide. So I had some plugin authors work against the new version, work against Python 3, figure out the common pitfalls that they encountered during this, and then tell me about it and document all of that in a long document on the page. I also threw Python compatibility information in plugins and the plugin repository so that OctoPrint would be able to look at a plugin's code and know whether it could even load that under Python 3 or not. So as to not cause any nasty surprises for users who would just try to load a plugin that is Python 2 compatible only under Python 3. I rolled out early preview versions of Python 3 compatible OctoPrint for everyone, well, primarily plugin authors, but also end users to test against and see if everything was still working as expected, and if not, fix it in time and make it compatible to both. And I mentioned the plugin repository already. We also switched that to requiring newly registered plugins to support, at the very least, Python 2 and 3 starting in late 2019. If a plugin author decided they only wanted to support Python 3, that was of course also fine, but Python 2 only plugins were banned from a certain point. Then, just before the first lockdown in Germany, actually, I released OctoPrint 1.4.0 that supported Python 2 and 3 on March 4th, 2020. The release went very smooth. The only problem was that some users were confused because they thought OctoPrint was now only supporting Python 3, but that was a communication issue that thankfully was quickly handled with a FAQ entry. And since then, we've been more or less in ongoing migration mode. So users are asked to report any kind of incompatibilities with plugins that they discover with OctoPrint running under Python 3 to the respective plugin authors so that they can migrate them and make them compatible. We also, the community, or rather someone from the community, also created a migration script that allows old image installs that still ship with a Python 2 virtual environment to be swapped over to a Python 3 image with, pretty much next to no input needed from the or action needed from the end users. So all they had to do was just enter one command into the command line, the scary one, and then everything got migrated, their plugins got migrated and all that. And that was really well accepted. And also we are, the community is now doing some motivation to get people to move over to Python 3 with their existing instances. By, first of all, we discovered that OctoPrint is performing way, way better under Python 3. And also some plugin authors decided enough is enough and made their plugins Python 3 only. And that has also worked as a nice motivator. And because it's always nice to look at some fancy graphs when saying something like this, I've brought this. So this is the compatibility, Python 3 compatibility of OctoPrint plugins that are registered in the OctoPrint plugin repository. Sadly, I only have the data starting in May of 2020. And the yellow line is the amount of plugins that are Python 3 compatible. And you see that pretty much right after the launch, the release of OctoPrint 1.4.0 with Python 3 compatibility in March, we were still somewhere around 33% or something like that. But there was a lot of growth because plugin authors saw, oh, there's suddenly a Python 3 compatible OctoPrint version. We need to get stuff going now. And then I also discovered that the compatibility information for some plugins in the plugin repository was actually outdated. That was the first big jump there. The second big jump is the Python 3 migration script in September that I mentioned. Then there was also the release of the new the new OctoPy image with Python 3 on board. And all of that has led to a steady growth. And we are now at something like 80% Python 3 compatibility in the ecosystem. I guess the rest, the leftover 20% are probably abandoned by this point. So once OctoPrint switches to full Python 3 compatible only, Python 3 only compatibility, we'll know for good. Some of them will probably be adopted, and those who are not going to be adopted, well, might not have been as interesting. Okay, so lessons learned here is read changelogs of dependencies if you can find them, and use version pinning to your advantage. You really do not want a third-party dependency to make stuff stop working for your end user somewhere in the field, which then do absolutely not know what to do here. Be prepared to work around breaking changes. Wrappers and sometimes even monkey patching can be your friend here. And most importantly of all is really just keep the ecosystem worth living in. Even with this huge migration with Python 2 to Python 3, we still have a lot of motivation by plugin authors to work in this system. And we still get users that are like, well, this plugin system is amazing and OctoPrint is amazing. So apparently this has worked. And finally, the last challenge that I want to talk about briefly is performance. So we have one Python process here that has to serve a web interface and several clients connecting to it, also including over a WebSocket. Keeping a printer running, so constantly feeding it data, then plugins doing all of this as well. So this is a ton of stuff that is going on. And all of this is locked to one thread at a time, thanks to the global interpreter lock. If I had known about the global interpreter lock back in 2012 when I started this as a pretty much Python newbie, I would probably have chosen a different architecture. I mean, not Python, but a different architecture internally. But as things are now, I'm stuck with it. The problem here is that a lot of OctoPrint's tasks are not I/O bound, but they are CPU bound. So checksums need to be calculated, or data needs to be processed, stuff like that. So it is not as easy to just say we can throw it into some other place and or just use async and everything will work fine. And thanks to data sharing with plugins, or rather between core and plugins being necessary, yeah, that also makes multiple processes a bit difficult, because now you also need to look at how you do actual data sharing and pretty much inter-process communication and things like this. And this is actually something that I still have not figured out. And as I said, if I had known about the GIL a bit sooner, or back in late 2012, as someone coming from the Java world, I would probably kept that in mind and designed accordingly, but now I have to somehow work around it. And this is still ongoing. And yeah, as I said, finally, the underlying platform, the Raspberry Pi or other single board PCBs, are usually somewhat limited in resources. Modern Pis have like 4 cores and up to 8 gigabytes of RAM, so it's become better, but still it's something where you really need to keep, yeah, every single change, with every single change, you have to keep in mind how it might impact performance at this point. So I'm not anymore in the comfortable position that I can just say, I'll just throw in this feature and everything will work as before, because features need additional resources, and that always means I have to think hard if I really want to do that. Yeah, lessons learned here. Look, that I made good experience with trying to actually extract CPU-bound tasks as much as possible into their own processes. So stuff like file analysis of the stuff that is supposed to be sent to the printer to look how big it is going to be and how much filament it is going to use and stuff. These are things that you can really nicely extract into their own processes. In general, be very conservative with resources, because even small changes can mean that it stops working efficiently for someone, and now their prints are no longer going through smoothly. And yeah, this is more like a to-do for me than a lesson learned. Explore IPC options and also maybe native bindings here and there. So I actually want to take a closer look at Python for that matter, and see if it can maybe help me in making some stuff a bit more performant, especially in the communication layer with the printer. And that already was my show. I want to thank you for your attention and for being here. Also, I want to thank the organizers for allowing me to be here. And yeah, if you want to get in touch or something, my Twitter handle is Foozle. You can also find me on GitHub under that and pretty much everywhere else. And yeah, my website is also foozle.net. And as I said, anything about OctoPrint you can find on octoprint.org. Thank you.
Okay, thank you, Gina. That was really nice, super interesting. We have a few minutes and we have some questions, so I'm going to start asking those. So maybe we can reply. You can reply to all of them. So the first one is, people is asking if you are running the project alone, and they're saying, yeah, it seems like a lot of work. So they want to know if you have people contributing. Maybe they want to join. So
I don't have a small team, so I'm the only one who works on it full time. I have some regular contributors. I also have some very enthusiastic plugin authors and people who help me with all of the community management all around. But if you look at the commit history, I think it's pretty much still something like 90% or so that is mine, or maybe more. I don't know. I actually have not run stats on it, to be honest. But yeah, a lot of people think I'm at least 12 men usually, because, oh my God, a woman with an open source project, that cannot possibly be me. But no, it's really primarily just me.
Okay, so good time for everyone to take a look to your GitHub and help you. So the second question is, were you able to reach the plugin authors to rework the plugins for Python 3? And how long was the process of migrating the most plugins?
So the thing is that I do regular devlogs for the community called OctoPrint on Air, and this is also where all of this obviously prominently featured, and a lot of plugin authors are watching these. So that was one way to reach at least the majority of them. A lot of them are also active on our forums and on our Discord, and that also helped in getting the word out, so to speak. And the rest then was actually done by the end user. So we had one plugin author actually write a little plugin that would flag all the plugins in someone's installation that were not Python 3 compatible. And then it even had a little button to open a GitHub ticket directly, which turned out to be not that good of an idea, because suddenly some plugin authors were swamped with 20 identical tickets that pretty much said, please update to Python 3. So that had to be changed again, but it worked nicely. So the crowd showed that it wants to keep using these plugins and actually help there. Yeah, and the migration seems to have been quite painless for most. Of course, some things are a bit tricky. So for example, if you do a lot, if for some reason you did a lot of string processing somewhere and did not really take care of the whole bytes versus Unicode situation, then that was quite painful. And yeah, I would have to look into the migration guide now, but there were some other pitfalls that really made people stumble, myself included. But that's thankfully now documented. So yeah.
Okay, so I think we have time for the last one. Maybe you were replying to that in your slides, but they were asking if using multiprocessing shared memory will help your problem.
Maybe. The problem is that the way that OctoPrint itself gets started up has so far caused me a lot of gray hair with using multiprocessing. So I actually have not yet been able to get it to work without something breaking absolutely spectacularly. So I'm actually looking into an alternative, but yeah.
Cool. Okay, so we are just on time. So thank you very much for being presenting here. It's super important to have you, like speakers, in this conference. Otherwise, it's going to be super boring. And I hope I see you next year again. And
I hope
for
so too.
everyone else, if you want to continue the discussion or ask questions, you can go to WonderMe and talk using your cameras, or you can find Gina on the Matrix chat. So thank you very much.
Bye-bye. Thank you.